Okay, welcome to my video for Math 115, Chapter 4. This is about elections, the mathematics of elections. Okay, we're in the first section, basic elements of an election. Really the only thing I want to highlight in this section is the bit about preference schedules. So a preference schedule is a way of organizing the voting, the results of an election. And what's going to happen is it's built on the idea that people tend to vote in patterns like, so what's happening here in this one, this is a preference schedule for a City of Kingsbury mayoral election, all right? And so what this is saying, see the 93 here, 93 there, it says 93 people voted this way. They had A first, B second, C third, D fourth, and E fifth. 44 people had it as B, and then D, and then E, and then C, and then A. See that? 10 people had C, A, E, B, D. For all of these preference schedules, people are not just going to vote for who they want, they're going to vote, they're going to put a ranking on all the candidates. All right? So let's fill one out for us. So these, in this question here, it says the table below shows preference ballots. In other words, ballots that list all three candidates and give the preferences, you know, the rank order for all of them, for an election with 16 voters, and then fill out the preference schedule, okay? So in this one, to make things a little simpler for us, all right, what we've got is we've only got three different patterns. Everybody votes either ABC or BCA or CBA, all right? And so we just need to count up how many go in each category. ABC, BCA, CBA, and let's see, so let's tally them. BCA is 1, BCA 2, BCA 3, BCA 4, BCA 5, BCA 6, BCA, there's 7 BCAs. What about, okay, so here's an ABC. ABC 1, ABC 2, ABC 3, ABC 4. Looks like 4 ABCs, and all the rest better be CBAs. CBA 1, CBA 2, CBA 3, CBA 4, CBA 5, right? All right, so our answers then would just be 4, 7, 5, and that's it for that one. Okay, let's go on to section 4.2. The plurality method. So the next 4.2 through 4.5 are different methods of counting votes, and actually all of these methods are used in different places, different election rules. The plurality method, the main feature is that it's simple. You just count first place votes. It's the most commonly used system, probably because it's the simplest. It does work well with 2 candidates, but not so well with more than 2 candidates, all right? And here's why. You can get a winner who has less than a majority, right? If you've got 3 candidates, one of them could win with 40%. There's an example in the book of this. The bigger issue, though, I think, is that something called a Condorcet candidate might not win. So what's a Condorcet candidate? Well, a Condorcet candidate is a candidate that is preferred head-to-head over every other candidate. In other words, let's say we've got 3 candidates, A, B, and C. A might win with 40% of the vote. But if it were just A and B, all right, B would win. Heck, and even if it were just B and C, B would still win. You can so what happens though in a case like this? You got A, B, and C. Let's just think Democrat, Republican. A gets 40. A is the Republican. B and C are both Democrats. A gets 40% of the vote, which is basically the Republican vote in this case, and whichever independents vote Republican. And then B and C though split the Democratic vote. Neither one of them getting to 40. Okay. B gets like, say 35%, C gets 25, right? A has won, but if C wasn't in the election, B would have beat A easily because he would have gotten most of C's votes. Even if A wasn't in the election, B still would have won, possibly, okay? This is the problem. In a sense, when you've got more than one person, you elect somebody who's really not the preferred candidate, okay? They give another example of this in the book if you want to look at it, example 3. So let's look at this question below, and we will do this by the plurality method. These are quick questions because, again, it's simple. You just count the first place votes. Using the voting methods applet, I'm not going to use that in this chapter. It doesn't seem to save me any time. In some of the other chapters, they have applets I'll be using. The Timbuktu University snow ski team is planning to host an invitational race event. They must conduct a vote to determine the event date. The dates they have to choose from are, so they've got A, B, C, and D, and the different dates. All right. So let's see who wins. So all we care about are first place votes, right? A, B, C, D. Well, if you look across the first place line, A gets 0, B gets 1, 2, 3, 4, 5. C gets 1, 2, 3, 4. D gets 1, 2. All right, B's the winner. Told you those were quick. All right, just a matter of remembering what you're supposed to do there. Nine times 4, 4, 4 times 3, 2 times 2, Okay, so I used my calculator to do the math, just do the calculation here, all right, for each one. So what I get here is A is 64, B is 62, C is 46, D is 58. Now as a check, what we can do here, so I'm going to add all these up, I get 230, right? Now you'll notice, for the rest of the check, you notice each of the columns has a 1, a 2, a 3, and a 4 in it, right? So if you add up each column, there's 10 points available in each column. There were 9 of these, so 9 times 10 means there's 90 points in this column, right? So let's do the total. Well, if you add all the numbers across here, you get 23 votes, each one worth 10. 23 times 10 is 230. And see, these two match like they should, all right? So it looks like I did not, no mistakes there. Okay, so let's look. All right, let's see what's the highest score. Well, the highest is A with 64. Next highest is B with 62. Next highest is D this time with 58, and then C. So there's our order: A first, B second, D third, and C came in last. And that is it for the board account method.